Today I'm talking about Next.js, which I hope many of you are already familiar with it, but if not, it's a simple framework for server-rendered universal applications with React. The main idea is very similar to what Tom was talking about with Create React App. There is an opportunity to make starting with React development much easier, but at the same time, there's an opportunity to make it really, really simple by taking advantage of the fact that React is a very universal paradigm as it is for any kind of UI-related work. So before I go on with the talk and all these ideas and features, I'm going to define some of the things that I want to talk about today. So by universal, I mean that it works everywhere. So we can decide to do some work ahead of time on the server, stream it to the client, and the client can pick up and do more work. On both ends, you can share code, views, etc. React is cool tech, I hear. It's easy, and this one is actually, so to speak, easy to come up with because Next makes starting a project with one command, so it's kind of indisputably easy. But the more interesting claim that I'm going to try to prove today is it actually simple? So some of the ideas that I refer to when I talk about simple are, for example, well-defined boundaries of the project. What is it exactly that it does, and where are the limits of what it does? And where does user land start, and where do other community projects begin? Does it actually support emergent behavior? And by this I mean, can it take other simple pieces to create more complex and more interesting projects and applications? And does it behave predictably and consistently? So a lot of the ideas that Next takes, for example, for how it performs navigation, are actually taken from the browser. A lot of what it's trying to do is merging the world of how the web used to work with all the new exciting possibilities that heavy and fat clients come with. And by predictably and consistently, I also mean that it takes you only little time to learn, and you probably can go through the entire README in maybe like 10, 20 minutes. So we take the simplicity of React, we make it easy to use so that we can amplify its reach. So ideally, everyone can create any sort of UI application with this. And it all started with a paradox for me because I spent a lot of time, probably like many of you here, on Hacker News. The paradox is, how does a website with so many trolls stick around today? No, just kidding. The paradox is, how come we're all debating like all this like awesome futuristic UI paradigms and like state management tools on a website that largely hasn't been changed since 2007, probably way back. It's really awesome 1990s tech. No JavaScript, no single-page application, no framework rewrite every month or every day. And the answer is actually because, in my opinion, it works really well. It loads fast. The server, from what I've read, has an in-memory cache of all the stories that, the data set's not that big. They produce some templates that start rendering right away. It's as good as it gets, actually. Building Hacker News is probably easy and simple, for it has remained this way for a very long time unchanged. It's survived without having to do much, and it still performs its duties relatively well. So I wanted my solution to this problem, that is creating universal applications, to be able to straddle across this really powerful client-oriented applications, but also serve the needs of simpler apps like that. So you could create a documentation website, or you could create a really powerful real-time chat application. And the invariant is, I obviously want React, and I obviously want JavaScript. So the first thing I set out to do was clone Hacker News pixel by pixel. So I created this thing called Next News, which, as you can see, looks pretty much pixel by pixel like Hacker News. And the paradox also, you could answer, if you do everything in React, if you're such a big fan, name 3 albums. So why is think written Keynote? And so last night I said, okay, I'm actually going to write this in Next as well, because I can show some interesting features as well, even when creating a deck. So for example, I actually embedded another Next application inside this Next application. So we went through some really interesting challenges to make sure it's, to the extent that it's possible with the web, these components are fractal. Another interesting thing that we did was the ability, for example, to take different paths if you come from the server to the client. So, for example, that animation that you see, if you perform a full refresh of the application, we're not going to trigger it again. So you saw there was no flickering at all whatsoever. So we're taking a slight detours from the server path and the client path. So this is one of the strengths of Next that I'll go more deeply into later. So it's not jokes out, cats out of the bag. It's a server-rendered application with dynamic routing. So something interesting as well is I wanted to show what the code of an entry point, which is a top-level component within Next, looked like. So what I did was I extended our Babel configuration, which you can do in package.json, and I included a plugin that allows me to include the source of the component inside the component. So here what we're looking at is a definition of a top-level component for Next. So you can see that it simply exports, in this case, a stateless function. We can go more deeply into this subject later on. At Zeit, we're moving into pure component exports more frequently. So the top-level component is the slide, which is a higher-order component that sets up the keyboard interaction. Later on, we can add, for example, swipe gestures and so on. And each page defines the entire universe of the application. So this is an interesting concept because each page doesn't have, there's no idea of like a global layout, for example. And in the case of Hacker News, actually, we have some examples where that actually ended up being really powerful to the extent that we wanted to clone Hacker News. Because, for example, they have a very interesting login page that has no layout whatsoever. But it's cool because it kind of challenges us to not, for example, impose a global behavior into applications. So moving forward, Next has been in use at Zeit for a long time. It's actually gone through many iterations. So at Zeit, our goal is to make deployment really easy to use and really scalable. So one command or two at most, maybe three. But so for example, this deck itself is hosted on Now. Every time you deploy, you get a new application immediately. You can start streaming it. So there are a lot of really cool things that you can do on the web as far as analyzing your deployments. So we make use of React extensively for that. And we've learned quite a bit about our own framework. So this is what our site looks like. And once again, I embedded it somewhat partially. If you right-click the logo, you can access our logos, which is kind of cool. And I'm going to talk about how we preload things dynamically to pull that off. So all in all, I'm going to share some principles, patterns, challenges, and the future direction, some of which are influenced by the very work that's being done on React Fiber today. So the main principle is that we start off with multiple entry points. So we have this idea that there is a lot of use and there is a lot of benefits to minimal convention. If you really think about it, you already have minimal convention with Node.js. It makes you create a package.json file. And NPM makes you define dependencies lists. And an NPM start project sort of guides you for how do I get started using this thing. So our minimal convention is based on two things. Sophisticated applications always have multiple entry points. There is no going around that. Many applications have different routes, different views, different ways that the user can enter and approach the data. Number two, loading more code than necessary is actually bad for many different reasons. Initialization time and download time being two. And this is actually widely applicable. It's a generalizable thing. While this GIF loads, I'll entertain you with the example of even command line applications. So command line applications, bear with the speed of downloading this GIF. If not carefully code split, you can see how, for example, the run code path of NPM is adding actually 500 milliseconds to your application. This is actually a recent factoid that I learned from VJukes recently. But it's really interesting to me because you can see how code splitting the different entry points of your CLI can be really useful. So that if you're running your program version, you're actually not loading the code for anything else. So each subcommand in that context is a different entry point. Code splitting fixes what I call the SPA, or single page application syndrome, which is you download the code for changing your password when you're going to see a photo profile or a selfie or something like that. So the convention in Next.js, simply put, is you start off with a pages directory. And that's where your entry points or top-level components live. And this is what it looks like in Finder. So you have your pages directory, and that's your files. So what's interesting about the HackerNews experiment is because it was before the fancy routing era, I was able to actually map it completely with a file system and using query strings, which is not bad. And the thing that is interesting about this is that there's an emergent, nice little convention that I've seen most people in the community follow, which is you put your entry points in pages. Typically, those are the ones that trigger data fetching, or they're the organizers of the different layouts of your application. So your different shells, for example. And then you have components that are the building blocks of the UI. And then lib probably has to do with like data fetching and data transformation. There are two interesting things for teams in particular, two interesting consequences of this organization. One is the work that is done in a subtree of a different entry point doesn't impact the subtree of another entry point. So if someone is adding a lot of bloat to a particular endpoint of the application, it doesn't really impact the performance of your endpoint. That's really nice when collaborating or scaling an organization. Secondly, this emerging distinction between what a top-level component does and what the lower-level components do leads to a really awesome component gallery sort of out of the box that you get. So what I call it is a SketchUp in the browser. And this is me loading our component library. So as you can see, everything that our engineers do lives here, and we can sort of demonstrate it with different configurations of data. So for example, this user toggle component admits only 16 characters, but if you use the SF font, 16 Ws are actually really wide. So you really want to test these things, or you cannot sleep at night. So top-level components are the organizing components, and optionally they can define a getInitialProps hook that gets the initial props of that component. This is useful in the context of pre-populating data that comes with that when you first load that component. You can decide how much or how little of the page to render. To the extent that a getInitialProps will be with us forever is still up to debate. I think even with the ability to down the tree lazily or asynchronously fetch data, I think there are some interesting use cases there. But there are two things that you want to keep in mind when deciding how much of the data you want to serve with that initial download. And I frame it as two different questions. So one is, what is the critical datum, or what is the critical information the user is after in that particular entry point? So in Next.js, if you go to /news, it's news. So what do we do for that case is, we render a list. Now, how many items you want to pre-render kind of depends on what your expectations are of the viewport, or how much in a premature optimization mood you're in that very day. But there's no harm in this case in doing it, and I've benchmarked this example quite a bit, and there are no substantial throughput differences between 5, 10, 20 stories. Then we have the item endpoint, which receives an ID. And just to take a slight departure from the original, I decided to show off how you can sort of branch. See, in this case, Firebase takes a while, so we show a loading message. So depending on the speed of the server, that's the second interesting deciding factor. Depending on the speed of the server, you might want to pre-render or not, because that gives you the flexibility to, like I said, display a shell, perhaps do something to entertain the user, like a mini game, perhaps Pac-Man with some sort of Konami code. So as another example, I was setting out to clone Instagram, called Nextgram, very creative. And I went to this Explorer page, and I think this is a great use case of not wanting to preload the data, because there is computational cost to saying who you should discover. And the option here is, what do we want to show? Do we want to show the browser's UA, the UI's UI, so perhaps some sort of loading bar, or do you want to sort of take over and load your own shell and do your own thing? So pre-rendering as soon as possible is probably a better idea in some cases, just because you give the user just something to stay entertained. And in a lot of applications, you can actually have a cache that's pre-populated that's on the client. So there's a nice hybrid opportunity here, which is reconciliation upon the client loading, rehydrating that initial data set that you were interested in, and then diffing it. So maybe you already knew of some recommendations, and then on the background, what you do is you load more recommendations, and then you invalidate them. Prefetching is another really awesome pattern that comes with this. So every link, higher order component, link is what we use to switch between these entry points, and has a prefetch attribute, and that's all it takes to perform prefetching. Link exists for a very, very specific reason. If Next already does server rendering, why do we need to supplant these entry points without doing a full refresh? And the answer is we don't want to lose client state in a lot of cases. So a critical example for us is authentication. We want to load the user once on the server side, because the server then can decide what sort of path the user will follow. Will the user go through a marketing website, or will the user have its notifications pre-populated, or will the user continue a path of, oh, you're in the dashboard or whatever. So you want to load the user once, then you can keep it in global state, you don't refetch, and synchronize upon change. So this is a GIF where on the left-hand side, I'm going to switch between pages. Should have transcoded to MP4. So, and when I switch, we're not fetching the user again, so that transition is immediate. I mean, the entire top-level component is being replaced, but it's actually getting the user from its global store. So that's a very neat pattern, and then we are actually able to synchronize it. So if we log out on the left-hand side, we're able to transform the state of where the other user is on the right-hand side. And even though they are diverging in where they are in the layouts, they both are logged out, which is pretty awesome. So with prefetching combined with server-side rendering, we achieve this nirvana, so to speak, of, it behaves like a single-page application in that it can maintain global state, client state. It can be very quick most of the time. And it also has the performance of a website from the 90s, which is awesome. Another interesting pattern is what we call route masking. So in the beginning, I mentioned, by default, we take each page and we expose it as a server route. So if you define the page A and you go to A, we render that top-level component. However, and this is where things get really interesting, the server can say, well, actually, you're not going to that top-level component, you're going somewhere else. So we impose as a design constraint on ourselves that the client at any given time should not know the entire route map of the application. We shouldn't have to keep in memory or download every single possibility of routing. Instead, it can always be a negotiation between server and client. So in the case of Instagram, for example, they have /p/ some sort of UID. What we do is we take that URL, we parse it, and we translate it into a top-level component that receives a query. So this is kind of neat because on the base level, it becomes a basic URL. It's a resource that receives a query, just sort of like how, again, the internet was sort of designed to work. But then what happens when you're on the client side and you want to say, OK, that particular URL has to display differently, provided that we maintain that constraint that we don't know exactly what every route should look like. So we can basically come up with components. Imagine here I could have a link photo component that sort of abstracts this out, and I pass it a UID, and it figures out the rest. But then I can incorporate these components as I need, and I'm sort of completing the route map on demand. So I have an example of this with Nextgram, but I'm querying a GIF, an animated GIF gallery, so I don't know if our internet connection will allow it. We'll see. If not, I'm going to have to jump. We can check the timeline. All right, it's not too bad. So what we have here is a Instagram thingy that queries a bunch of animated GIFs. So this is what I call, this is what I refer to by route masking. Let me exit full screen here. So what we have here is Instagram actually does this. They push an entry into their stack that refers to a photo, but when you actually go to that photo as a permalink, it looks completely different. So what we have here is we have two different top-level components that are answering a certain URL. So even if I refresh here, you're going to see that it sort of merges into and it sort of resolves into the other one. So this is cool because you can see how you have the flexibility of doing routing any way you want with any sort of URL pattern you want. No limitations there. So each of these attributes that I described have their imperative counterparts. This is cool because I mentioned earlier that when you right-click our logo on our website, we show the logos page. So that's not a direct link to the logos page. It's something that happens on hover. So what we do is when you hover the logo, in case you ever right-click it, we prefetch it on demand. So that's why we have this basically correspondence between the tags and the imperative APIs. The other neat thing that we discovered is, well, it wasn't neat in the beginning, but then it became neat, is to pull off hot module replacement in a very, very large code base. Building on top of Webpack, we hit some limitations with regards to how many components were being watched and rebuilt upon every change. So as our project kept growing in terms of number of components and size, the situation became really bad, especially if you were editing a component that was depending on by a bunch of other pages, etc. So what we do now is, since we already started with that minimal convention of separating your routes or top-level components, if you're rendering a top-level component in one or many tabs, we only watch and rebuild those. So that's yielded an amazing iteration improvement for us. It went from being super annoying and not really liking hot module replacement to now it's pretty good. OK. The other really interesting thing that this lazy loading model comes with is what happens to the build as time goes by. And by that, I refer to what happens when people are deploying constantly and altering the builds in many significant ways. So the question is, if everything is changing and you're loading components lazily, how do we deal with that? So we deal with that with content-addressable build artifacts. So when you're requesting /a, we're actually requesting a hash of what A represents. And there's an interesting conflict resolution step that happens with this. What happens if you try to retrieve it and the server has moved on from that build? And it doesn't make sense even in the context of the overarching document anymore. So when there is a mismatch, we can actually we invoke a hook in case you want to save state somehow, or do an error notification or do some measurements. But otherwise, we perform by default a full page transition, which is a nice fallback compared to the alternative of, in some cases doing nothing, in some cases rendering an error that is not really actionable by the user. The other really interesting thing that we decided was to not go with a specific pattern for fetching data. So if you want, you can keep a global store. And the server side, you can await dispatching an action to populate it, and then serve it to the client, and then take over. So this is an example of using React Redux with one of our top-level components. Something that's awesome is our community has submitted a ton of examples to a repo. So if you go to the examples repo, you'll see examples for Redux, MobX, RefNux. I don't know what it is. Apollo. I know what that is, and so these are constantly being updated and improved. So it's really awesome to see. Specifically, some of these, I think the Apollo one recently got updated to do this idea of hydrating when the client loads and reconciliating the data set, et cetera. It's pretty cool. The other thing we wanted to maintain agnosticism over was how you style your stuff. So the easiest and most exportable way in the React world, bar none, is inline styles. So of course you can do that. You just use inline styles. Beautiful. The problem is, and I have a personal vendetta with inline styles. I'm coming out. It's only a strong subset of CSS, right? So no surprises there. So no media queries, no animations, no font declarations, no hover states, no pseudo elements. For now, I think some of these could be added. But I think those are just symptoms. I think the main issue is that CSS is co-evolving A lot of people are currently making extensions and improvements to the language and so on. So I think it's an opportunity that we should definitely keep open. So if CSS continues to evolve, we should find ways to incorporate it. So the solution that we came up with was style JSX. So what it does is it isolates the styles to a component. The thing that is not neat about CSS is that the defaults of how people use it is you style the entire world. Paragraph, it's every paragraph. And then you have to be like a human compiler where like you prefix and you come up with your own schemes for not affecting the work of others. So what we're trying to do with style JSX is you give us something like this, and we scope it to that component statically. Limitations. If you use React.createElement, we're not able to, for now, I mean, we could go through the trouble, but we're not adding the necessary attributes. And otherwise, it's just CSS, maintains the specificity, and the full power of CSS is enabled for your component. And of course, it's not a software as a default, but you can turn it off somewhat for now, but then we're going to add it as an option to the Babel preset so that you can really turn it off. And what it really fixes is a global CSS injection problem. So out of the box, StyleJSX dedupes, which means if you have 1,000 components that use a style tag, we only embed one in the page. It detaches, which means if your page is gone or your components are gone, no lingering style tags, and it sort of renders out of the box. So your style tags are co-located with the first appearance of the component, which makes that pattern of you want to pre-render and you don't want to pre-render stuff that is not styled work really well. So this has been by far the most controversial thing in the world, I think, because we've received so many examples, some of which I cannot even tell apart from one another. So basic CSS is how the framework does it by default, and then you have a lot of interesting options with all different trade-offs. The last three, the global style sheet and scope style sheets are the answer to, I have existing global or big style sheets with SAS and stuff like that. That's one of our top support issues is how do I bring in a huge style sheet into the project? And what we're trying to tell users is, well, try to think of embedding, co-locating your styles with the component that you're using. So instead of bringing bootstrap.css, you sort of bring bootstrap button, and it contains the bootstrap styles. So this is definitely something that the community is going in a lot of different directions, and it's going to be interesting to see where that goes. Babel extensions are really interesting. As I showed earlier, we have some for meta programming. You can use the next Babel preset and then just extend it. So you edit your package.json file. I came up with this example, which I'm particularly really interested in, which is by at 3.1, spelled out. You can include a Markdown preprocessor. But the really awesome thing about this is that he's giving us an API to bind the Markdown pieces to actual components. So we don't go back to the mess of global tags and styles. So this is really awesome. I haven't experimented enough with it yet, but I'm really excited. And there are 3 other examples in there for Babel stuff. So Flow for stripping annotations and custom Babel configs, and one for replacing process.env.whatever with, or any expression with something compiled ahead of time. One of the last things I want to talk about is server extensions. So this example, which maybe the text is not big enough, but let's see if my layout is Zoom friendly. You can see how I initialize Express, and then I use Express for route matching. So the bottom line is you can sort of use anything that you want on the server. You can even boot up the entire stack, including the watcher and the Webpack and everything programmatically. Very cool. Shout out to Webpack for having an awesome API. So another cool thing about the server parts is you can do some really interesting caching at that level. And this is a crucial technique for now for improving SSR performance in the React world. Another one is you can use alternative renderers. So we have another example of using Inferno and using module alias and the Webpack alias as well. And with all that alias, magic happens, and it's quite a bit faster for certain workloads. But our benchmarks are lacking so far, so I can't outright say, switch to Inferno, but we can say hire the Inferno guy, and let's make React better. So with React Fiber, streaming is possible. And this is obviously really exciting because in terms of throughput, we can interleave a lot of work, especially with, for example, lazily fetched components or data sets. And we already have quite a few also examples for doing different stuff on the back end with different server frameworks. So I'll quickly go over some of the exciting new directions for what we're doing. So import support is somewhat already in, but we haven't really tested some of the failure scenarios. So for example, what happens if you're importing dynamic component subtree, and again, there's been a deployment and there is a mismatch, and what you wanted is the previous version of dynamic component that corresponded with the build of your top-level component and so on. So how do we manage this stuff at scale so that developers can just push, push, push and really not worry about this stuff? So one of the things that we're going to try out is, because all our bundles are content addressable, we use cache control immutable, which means a CDN in front can cache forever. So as we continue to roll out, even in the middle of a rollout of our backend of Next, if clients are requesting bundles that the server doesn't even know about anymore, they're going to be answered by the CDN. So as long as the APIs are compatible for how you fetch the data, which is another story, you should have a no-worry path for continuous development and iteration in your code base. And perhaps the most interesting to me is lazily loading components based on data. So an example that we're putting together is, imagine a messenger where you have different message types, and you want a server render the markup according to the data needs of that particular thread. And then you want the client to pick up where that left off, reconciliate by fetching the specific bundles that were used there, and resume the work. And if new messages come, lazy load those messages as well. The other really cool thing is, for development mode, which we're continuously iterating on, improving its performance, we can make it a lot more lightweight by trying to avoid as much work as possible that the browser or node are already doing. So there's an interesting situation right now, which is Node 7 is already really good, and they're keeping very up to date with all the latest developments, and they have Harmony flags for a lot of new features. And on the other hand, you have Chrome and Chrome Canary. So we're trying to think, what if we can make, hot code reloading near real time? So think about saving or even as you type and seeing those changes on your browser. So right now, we're quite a ways away from that. And I blame source map generation, just kidding. But there's a lot of really nitpicky things that we can take out there. Finally, by using link preload, we can take all our prefetching off of the main thread. We haven't found this to be an issue yet, and we prefetch really aggressively. But it really, I think, depends on each code base. You can also use a manual API to sort of create your own queue and set up priorities for prefetching if you have a lot of stuff to do. And those are the main three things. I forgot to mention here, we also are working on a different tool called Next.export that would allow you to define what you want the shape of your static files to look like, and whether you want to pre-populate data or not. And you can create a completely static HTML-based build of your project. I want to thank all these amazing contributors and co-creators of the framework for all their help and keeping the examples updated and figuring out the breaking changes and all that stuff. So I also want to announce that we're tagging the current master as 2.0, and we're looking forward to everyone using it. Thank you.